above that is mini category, and some of them, if their stay in the air is more than an hour, it would also come under military or civil category. So if the sustenance or its power in the flight, its ability to sustain is more than an hour in air, it would become under the military category. So we would probably elaborate more and how to lift. Okay, a drone works on the principle of the Bernoulli principle, just like even a regular aircraft, but it has a vertical takeoff and landing. And the trick is create a pressure above the body less than the pressure below, so that because that lift will be coming up. So that's how you make the rotating blades, the rotors, and that's how the Bernoulli principle works. So the research on that started in US by Wright brothers 1900, 1901, 1902, and also powered planes in 1903, 1904, 1905. So this is like that is the history of the regular aviation is common to even UAV history. Okay, and the constituents of a drone is it has a structure just like a motherboard, and it has ability to host electronic speed controllers and motors, and then on top you have those rotating blades, and then you have the autopilot and navigational electronics and GPS or Navic Indian satellite receivers, and command and control communication systems, and the payload such as a camera or other use case depending on the application. Command and control is something like the control plane. So maximum capacity for lifting of drones is very interesting, Krishna. A drone which is made by NASA, which is called as Global Hawk, which can lift more than tons of weight and will stay in the air for more than 35 hours. So a drone can lift more than Boeing 787 or Airbus 330 or so. So the drones have been built with heavy capabilities, but for regular use for civilian, usually they are 2 kilos or 15 kilos is what you could see in normal usages. Okay, security of drone is something a research topic. We are thinking of not trying to retrofit security after making everything, but from the design dates only. We are working with a lot of professionals like those from Bosch and other companies who are part of our studies of drone security in line with the international security standards. Okay, so drones have got a demarcation of maximum takeoff weight and its own body weight and the weight of the payload it carries. That's how we have to classify. Let's move to the next slide, please. So basically, we are looking at you to work on kind of remotely piloted vehicles as an intern with us, or do some long projects or short-term projects. And if you are already in a good hands because you have IEEE in Chandigarh, and you can work through your professors to write to us. So yes, ISRO also created a light drone which they acquired from Israel, Elbit, and they have been making CubeSats, working with some of the enthusiasts. Yeah, ISRO wants colleges to work with them to make small size drones and launch from their campuses. Yeah, right, that is true. The next slide, please. So basically, we're recently in an international cars flying vehicles. So why till now not to achieve motorcycles and cars are flying vehicles? See, actually, flying vehicles industry has been matured, but for some well-known reasons, the technology has been kept closely guarded secret right from Vietnam War. That is, I am talking about 1960s. It has been mostly restricted to research inside the closed doors by the military forces across the world. So civil world started to look at those applications last 10 years, that's all. So if you want to know a little bit more on the software side of it, you need to know the robotic operating system, and which works on Linux, as well as some versions work on Mac, as well as Microsoft OS Windows. And there is a PX4 autopilot and Pixoc framework and Unity, and even other tools like Katia also can be input to the framework to start building your drone prototypes. Okay, next slide, please. Yeah, there are many laws for governing the aeroplanes, including drones. That's what we are working on at our Bureau of Indian Standards, and you are welcome to contribute, Aryan. It's an interesting area. Okay, let's move. These are the different types of the Global Hawk I mentioned, that has a 34.5 meters length. These are different versions like Octocopter, etc. Global Hawk is very gigantic, and there's a big room required to park it. And this is the one with a conceptual framework of a fuel cell based drone. And we can replace the normal air traffic fuel of normal aircrafts with a fuel cell. Okay. 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 Now we will get back to your questions maybe soon after I finish my talk. I would focus on my talk now. Okay. Next slide, please. This has got two videos, slide 10. So sit back and relax and view these two slides, videos. If you have mobile phone, take a picture of my address and details coming up in this after this. You see here a scenario that in case two drones without their good intentions, they somehow come close to each other. Still, technology exists to avoid a collision. That is the main concept here. We can avoid collision in by adopting the best practices of how do we avoid hitting a car in front of you. You try to change the lane, and similar techniques can be used here as well. And additionally, you have additional advantage of going up or below, which you cannot do it on a road. So this is a make use of the space three-dimensionally to avoid collision, and that is where we are all working on various paradigms, how that automatically the collision can be avoided. Basically, by rule, you are not allowed to fly when there are other drones, because there is a no permission. Then there is no takeoff. Government will not give you the permission to multiple players in the same space, so that to avoid inherently to avoid collision. But in case that happens, these are the mitigation strategies, collision avoidance. So Suraj, you will get my address with a mobile phone. You can take a picture, and that's how you can get in touch later. So these are the mitigation strategies of collision avoidance. There is next we have a group of UAVs known as multi-UAV case study coming up. This is my address, my phone number, and my company. Okay. Organizers will help you to get in touch with me. Okay, let's play the other one. Thank you, Rishabh. Yeah, I will take up this drone related air taxi questions towards the end after my talk is over. So, okay, this is how we can have them getting back to their roots, and they can be lifting a mat together for any operation, including a rescue operation. Thank you very much. So we go to the slide number 11. So basically, my talk would have a content which has been made by consortium of UAS by America. They are closely working with NASA, and IEEE also has access to them. And AESS Bangalore gave some of that to uh, give a kind of knowledge to us. Also, IEEE has an office in Bangalore. That is not just Bangalore, it is restricted to not Bangalore. It is IEEE office for India, and that is in Bangalore. And there they built something known as a blended learning program for UAVs. And during my talk, I will also mention about that. Okay, next slide, please. Basically, there is a group that made a very interesting study in Mexico. A drone that mimics a bird, a hummingbird. This it is there already in YouTube. You can see that. And so I avoided already shown you two and another two videos there. So I avoided this hummingbird video. You can always get a hold of it by talking about hummingbird video this way. You can, if you see this in the internet, you can get a video like this. I encourage you to go through it later. So what it does is it has a bird like structure, so the butterflies don't antagonize this bird. Okay, next please. It's a butterfly swarm. They don't feel that some machine has come in midst of them. So next slide, please. So here, this bunch of butterflies, they don't feel that a new machine is in front of them. This is a camera shoot of the butterflies, live butterflies, and the drone by through another helicopter manned mission. But as you could see in the video, once you see after my talk in YouTube, it will take about 5 to 6 minutes to view completely. You see that butterflies don't feel antagonized by this machine. They will sit on top of it as if it's a bird. And so nature is friendly. So this bird mimicking the another bird, this drone gathers all the information, and that's one of the ways that they're mimicking the nature to do their job. Okay, next slide, please. So this can be considered as a spy UAV. Yeah. Next slide, please. Rishabh. Yeah. Move next, please. There's no video here. Just move. Yeah. There's no video in this. Yeah. Move to the next slide, please.
Actually, sir, he'll reshare the slide. Due to technical issue, the slides got stuck.
Oh, no problem.
Yeah. So he'll share the screen again.
Okay,
Yeah.
meanwhile, there is a question on taxi drones, so I will take up that question. So in New Delhi, very likely that between Connaught Place and Nehru Place or any other place, maybe Noida or Gurgaon, there might be the air taxis, and some team from Uber Air Taxi are already in touch with the Prime Minister's office, and it is very likely that they would deploy it after all the security clearances. So whenever that happens, maybe 5 years or 10 years max, but it can be even earlier than that. We have to wait and see the policy framework. Okay, next slide, please. Yeah, these are some of the drone models. We can quickly move over these just to give you glimpses of several. One of them may be recently deployed, known as Bharat drone by the DRDO in Chandigarh, and some more are, I think, just of interest, general interest. Yeah. Okay, move fast, please. Other 3-4 of these slides we can move over very quickly. This is maybe this is certainly a made by China DJI. This is something that India DRDO has made. Yes, and in the Ladakh area that is used for the survey. This is the latest information of less than 70 hours from now. This is a happening story. Bharat drone. Okay, next. Yeah. This is made by Chandigarh unit of DRDO Terminal Ballistics Research Laboratory. I think IEEE Chandigarh definitely can conduct some programs, invite them to give speeches, and DRDO has a extramural research and IPR. They can actually fund you for conducting programs with collaboration with the DRDO. Okay, next slide, please. That is made to work in high altitude, as you know, in that Leh Ladakh areas, and also in extremely extreme climates like very cold, like that. It is also very agile. Okay, next, please. Next slide. Yeah, yeah. Please move to the next slide. What is the principle of the drone and helicopter? No, the helicopters work on a different concept of having a rotor on the head and a tail rotor. Normally drones will have similar looking type of rotating, like a four rotating kind of a quadcopter, or maybe having more like octave, what you have seen. The principles are helicopter is different because that the turning, the like a yaw, roll and pitch, they are done differently in helicopter, but based on the body design. Whereas in regular drones it is based on Bernoulli principle. Yeah, CSSR Siri Pilani. Right, good. Okay, let's move to the next slide, please. Gyroscopes are there and gimbals are there, gyrosensors. There is also something known as inertial measurement unit, which is useful for giving a sense of whether the drone is stable or not, so that your camera pictures when you're taking, you can get a feedback whether it is stable in itself. Otherwise, when it is not stable, it won't take nice pictures. So that's how there's a gyrosensors and gimbal to have your camera adjusted properly to the shaking nature of the flights. Okay, next slide, please. I see only the DRDO slide in my.
Yes, sir. Actually, he might have some network issue. So by the time you can take some
Okay,
questions. Yeah.
right. Okay, sure. And what about flipping in drones? Okay, actually, drones don't do like that particular hummingbird drone, which is actually some of the drones like flies under very small weight drones are being used in defense purposes. They are like a mosquito drones, and where the wings will be flipping, and they are specially designed for certain coveted operations, and not really useful for civilian applications. They are, yeah, they may be flipping their wings. What sensors are used for detecting other drones? Yeah, that detection and avoid, we are talking remote identification. There is a concept of using the RFIDs and other techniques, like based on the design chipset level, and even blockchain is also being considered. It's an ongoing discussion about detect and avoid, and a lot of image, like a LiDAR is one technique that is used, and also visual imaging is also another technique used, and for alerting each other, visual indicators of color codes, as it has been shown in that initial slides. That is also one of the approaches. So detect and avoid is the concept of how do you detect other drones and how do you avoid colliding with them. And infrared sensors are also useful, and many other techniques too, like even light detection and ranging lidars, they're also quite useful. Yes. Yes, artificial intelligence is very much useful in the drones. As you would see the other slides that would come up, most of the decision making that you do, including for the likes of some of the applications wherein you have a mission critical application, especially in defense. The drones will identify a particular pattern on the ground based on the memory, machine learning, and AI. And when the same pattern happens, it would respond in a certain way, including it will be weaponized and it will be armed. And that is a way that AI ML can be used even for other contexts of dropping a safety jacket or releasing some medical supplies or some things like that. It can happen. Yeah, there can be brushless motors also, and we can make them radar. Yeah, we can also try to make drones which are not detectable by others. So that's also like a stealth technology, and they make some noise, and it's not so easy to get away with that. So we need to make much more research in avoiding noise or a flying machine. Okay, good. So I see then the slides containing the chipsets made by these people. That is, ISRO has contributed 7 satellites, of which six are operational. One we will have to relaunch again. And with those 6 satellites, we have something known as Indian constellation navigational with Indian constellation. So it is alternative to the GPS. The reason why every nation wants their own timing system is that when it comes to military objectives, a nation may not support you when it has some other interests contrary to your national aspirations. So there was a Kargil war, and America declined to support our military forces with the GPS support. So India needed a kind of its own satellite system to provide timing. And these are the chips which are used even in the Qualcomm chipsets, which are useful for the 5G phones and also for the base stations known as G Node Bs. The Broadcom also made, MediaTek also made, and a number of others too are lined up. So they will all be supporting the NAVIC. That will be the policy framework. Any manufacturer in India must make NAVIC support for the UAVs. That is Indian policy framework. Okay, next slide, please. So these are the 4G and 5G system on chips are also there. Okay, these are various kind of applications we can talk about. Drones can monitor water, they can get fire is going on, they can sense it before it becomes very wild. You know that Australia, Canada, America, quite recurrent. Even in India, in some states, we find that some oil and gas system has some pipeline has exploded. So in the early stage, if you detect before it becomes too big, then the damage can be controlled. So drones can be there in the control of, let us say, fire station or a police. They can launch them to the place before they can even reach there, because drones have the advantage of the height and the third dimension, and they can see better than what the cars can reach out to the spot. And by that time damage might have been done. So that is the advantage drones bring to the value chain. And they can also monitor the traffic, and law enforcement agencies can use drones to do certain operations of their interest. Okay, next. Underwater drones are also there. They are called differently, underwater autonomous vehicles, and also there is a ground vehicles, autonomous ground vehicles are also there. Okay, next slide, please. And there is a video here. After 2 videos, we will directly go to slide number 70, and then I want to spend remaining half an hour talking about other applications. So 2 slides, and afterwards we move to slide 70. This is a big 100+ slides, which is meant for 3 hours, but to generate interest, I am giving you the important ones. Here the individuals are marked with certain number system, which is interesting to know that even a walking pedestrian is marked as number 1, number 5, number 8 and 4. They are being monitored, and there is a way of identifying based on some features or patterns. they are humans, and that the system has an ability to do that kind of tracking. So we can actually monitor. So this is a moving target tracking, and there is a recursive random access based algorithm. Okay, next slide please. Oh, drones can use several type of cameras, including 30x and or higher zoom capabilities, so that they will get an idea of what enemy is doing. Here is a video which will give you an impression of a static ground looks like moving. It what is moving is the observer is moving. It is not what is observed that is moving. That's a parallax attempt. So the ground is not moving, but the body which is taking the pictures, that is moving. So you feel that there is a little bit of a play, and you can correct it by software. So when you are interested in the drone, apart from the domain knowledge of the drone, knowledge of photogrammetry and videography, image processing, computer vision, OpenCV, all the tools that you use for machine learning and the classification algorithms, outliers, they all will be helpful, k-mean, etc. So yeah, even GoPro is also good. Maybe they are not good for drone, but so drones have specific type of cameras, and I can maybe share that literature offline about the nature of cameras suitable for the drones. Okay, let's go to the slide number 70 now, and then I know that I have 20 minutes more to talk. Yeah, slide 70. Directly go to the slide 70. 70. Okay, this is about target tracking and following. So drones are used for some specific objective in mind, and that algorithm and a flight planning has to happen, and you need to have the software tools and necessary infrastructure to support you, including tethering. Tethering is a concept of powering the drone with a wire that is from the ground. It is as if you have tied it like a cow grazing a field. So there's a lot of infrastructure required to make a certain yeah, aerial mapping, etc. Okay, next slide please. Okay, it is also target tracking following, so ice tracking. Okay, let's play this. You see that 2x, that is the camera nature, that is the autonomous flight. 4x, so you are increasing your zoom because you are nearing to get to know more you are getting more closer, you're taking more magnified image. So you should have the programmable software controls to know what object you are interested in, and define it in a training program first, and then use it for that actual application. Okay, I know there are some Shiva Shankar, yeah, for increasing the range to 10 kilometers RC mode. So beyond 10-kilometer range, you need to, yeah, just right. So these are all good points to talk about. Okay, this is NVIDIA. So I will come to that beyond range and other techniques. So NVIDIA is a graphics maker. Here it's talking about a GPU, general purpose and the central processing unit details of CUDA processors. They are all useful for this image because you need to gather a lot of image data. So I can attach to the UAV with a Connect Tech Inc. Orbit carrier board to carry this image processing capability. That is why you are able to get those insights. Okay, that beyond 10 kilometers, you need to use either 4G or 5G. Normal RC, which is restricted in terms of their ability to support in terms of data rate and also the signaling that you can get from the regular RC, not possible at all. So you need to have other modules such as 4G stack or 5G stack in your UAVs. Okay, next slide, please. Okay, this is about the kind of to process some data that has been captured by the NVidia graphics system called Jetson TX2. You need around 30 milliseconds in total for all the things put together, including an algorithm known as a recursive ransack algorithm. And this basically it's one technique used by the consortium of UAS in America, and we are getting insights from them from IEEE channels. Aeronautical Engineering Society. Yeah. Next, please. Basically, I wish to now switch the gears to another topic. So here, what we went through those couple of videos is to tell that how do you use this UAV for multiple target tracking algorithms. There are some things known as recursive ransack algorithm, which you can look up in internet about that algorithm. And if you write to me, I will send you a write-up of 84 pages on the consortium of the UAS, which includes the studies done by Beard, Randy, others. We were listening to him recently in an IEEE AESS program. And yes, next, please. RFD 900U. Yeah, I already see Santosh has answered that question. Okay, good. I see that already some of you are well versed. I find some of you should work with us to take our mission forward. So what I'm going to do a little bit of selfishness about IEEE. We all want you to be part of IEEE if you are already not so. So IEEE helps you to advance all the technologies for humanity, and this is one learning curriculum we built, IEEE blended learning program, and it comes from IIT Mumbai sources. There's a drone aviation team has built it. We are proud to present it, and we can even work out economic package for your teams other than what is the stated price of it, and we can train you on the this particular IoT aspects of using embedded systems about UAVs. Okay, next slide, please. We will talk about various sensors and hardwares, how to interface. And this is an example of the ARM Cortex M architecture with general purpose input output. We will talk about interfaces and timers. You may be knowing 555 timer, but several other things, serial communication, serial to parallel interface and such things, programming for power efficient computing. That's most important in IoT and other. Wherever you develop any solution, if you can spend less power, it means you are very efficient in that, because power efficiency is very important to have sustainability. Okay, next slide, please. So basically, these are the things we will familiarize you when you sign up for this course in IEEE. We talk about ARM, and we will talk about the temperature sensors. We talk about how to turn it and flipping by giving XYZ random rotational commands. The drone may jump upside down and fall down also. We just want to get you that experience. It's a small form factor drone, and it's very relatively user friendly. It won't hurt even if it comes close to you. They are soft blades. And then turtle turn, and then you have a air pong, and we have certain things like make drone autonomously fly such that your drone never touches any walls, so it is a kind of a collision avoidance kind of characteristic. Hybrid drone, maneuver the drone with the ground control station like thing, and auto stabilization. These are all some of the small. Yeah, ARM serial, we will take you as offline. So we will take you in depth about this ARM core and other details, which is not part of our syllabus. Yeah, thank you. Okay, next slide, please. This is about our advertisement or the logo of our IEEE blended learning program. We also have other things relating to blockchain and other things. You can get in touch with IEEE Incorporation in Bangalore. Okay, next slide, please. Okay, this is a kind of a wind tunnel come the EMI EMC testing done for a small UAV, and we used LTE frequencies to do command and control along with that. And so the next slide, please. So environmental testing and electromagnetic compatibility and electromagnetic interference. And this is typically in India, we have a wireless planning cell, and Indian government will pick up some of these frequencies for authorization for use of UAVs, and they work with the telecom providers, and they may sign up to the government for two kinds of services. One is regular users like mobile phones. Second is the users who are using the this particular drone kind of things. And here we are showcasing the LTE bands, so 700 megahertz all the way up to 2500 megahertz TDD FDD bands. And every nation will have certain interests in some filters, and this is globally distributed. China will use some frequencies, America some, Europe and India, like this. Okay, next please. Yeah. So basically, now onwards, I'll talk about the 5G UAV concepts. And today itself, in fact, I am missing that speech. There is a professor, Arogya Swami Paul Rajan, is giving a talk in another forum parallel to my timing, and he's advising the government of India on 5G, 6G. I'm missing his speech on 6G. So we have a planning cell, and the forerunners of 5G UAV in India would be Airtel Reliance, mostly Reliance first and Airtel later. And UAV would be a UE. It can also be a relay G node B. Also, it can be a G node B. So it is something like a biblical statement of the God, the Holy Spirit, the God, the Holy Father, and the God, the Holy Son. So UAV can be a UE, the small baby, and also it can be a mediator between the, like, archangel in the role play between the UE and G node B, and also can be a G node B itself. These three roles is possible for a UAV to perform from the context of 5G wireless. Next slide, please. So basically, what we can do with the UAV is we have to look at air traffic management aspects of regular aircrafts, and how is air traffic managed by air traffic controllers. How do you manage in case of proliferation of these UAVs, maybe 5 to 10 years from now? How do you manage all that? And certainly, the existing air traffic controllers will be overburdened with that. There is a need for a drone airports and a skyports on rooftops of our buildings. Wherever H symbol is there, they are also suitable for the drones to land. And UTM is UAV traffic management, skyports, drone, helipads, smaller airports. Yes, India has a notional concept of Uday Aam Nagarik, Desh Ka Aam Nagarik, Prime Minister Narendra Modi's scheme, Udan scheme, all these airports, wherever traffic is less, you can actually have some section earmarked for the drone clubs to come up first. Later on, when they become perfected or commercialized, they can actually be like the drone ports. And they don't need much runway, therefore takeoff landing you can accommodate large number of drones. So that is a future scenario in 5 to 10 years. Okay, next slide, please. Helps in better pursuit guidance. So we need to, in fact, there is a video which I avoided for want of time. I have 10 more minutes to cover up the whole context and take some more questions. And pursuit guidance is when you are anchoring to one object with certain machine learning algorithm. Initially, you train the mapping image processing, then try to track it wherever that image is matching. That is machine is following it. So the terrain contour mapping based on a moving target based guidance system. So that pursuit guidance, whenever you miss, when do you miss? I'll tell you. In deserts, there is a rabbit which is chased by two dogs, and it is taking crisscrossing turns, like extremely high G turns, like fighter plane taking very big turns, like our wing commander Abhinandan and F-16. So the small MiG-21 was able to hit F-16 because F-16 body size was more. Its G turn was not as smart as it could be for MiG-21. So pursuit guidance means when an object takes quick turns, how are you able to proportionately make your navigation XYZ vectors movements in 3 dimensions, and to make that pursuing the object without missing the image. So camera movement can be automated. Okay, next slide, please. So basically UAVs, artificial intelligence, UAVs and machine learning, and UAVs and IoT are interrelated disciplines. So if you are interested in pursuits of any of these subjects, UAV and 5G can be a added value addition for you. Like, how small can we make a drone in size? Okay, a drone can be on your palm. It can be as small as on your fingertip. Already people have made a company by name SKEYE in Sweden has made a drone smallest in the Guinness Book of Records in their fingertips. Okay, next slide, please. Sensors, infrared, lidar, Li-Fi. So as the Wi-Fi, WLAN, if you go to higher frequencies, it is called Li-Fi. So UAV will deal with lidar, infrared, as already discussed by some of you in the chat. Sensors, several sensors, maybe temperature monitoring, or maybe for social distancing. If you have a very superior quality temperature monitoring, a drone can know that there are some violations of social distancing done by way of any of those kind of COVID-19 applications also can be done. In fact, they are using drones to clean the hospital beds on the COVID-19 patients, so that people need not worry about getting infected. So the drone will send clean it before staff have to come, and it can send a UV light, and that is how they were planning to do it in some use cases. Yeah. Okay. Next, please. Coverage filling. So there is a very interesting use case of a drone acting like a base station, which is to fill up a gap of exists in the regular telecommunication infrastructure. Something like in places like in Philippines or in Indonesia islands. There are thousands of islands, and you cannot have fiber optics. You cannot have wireless towers, but you can just send for a few hours on a need basis a drone which is just made to stay there and then provide coverage to the ground, and it is possible. And you can also use a drone to behave like a bird. It can be perching, means a bird will go and rest for some time on a branch of a tree, during which time over the night it may get recharged. It may also observe the ground scenario. It can pass the data back to the ground control system for a cloud. Lot of things it can do and plan its next mission. All the things can be done when it is resting after a mission, and once it comes back, another one maybe which is already ready, it may be taking charge of whatever job it was unable to do. It has come for rest, so it will go back to wherever it came from, leaving the battlefield, let us say. Like that, perching can be kind of a battlefield scenario to give continuous support of 24/7 to the scenarios where you need. And interoperability. So the biggest challenge is if one UAV is made by say Tata company, another is by Adani's. If these two work with each other, or Idea Forge drone works very well with the drone made by any other company, that is what we need to do, interoperability. Okay, next slide, please. Collision avoidance, we have seen some illustrations, and lot of research is going on, detect and avoid, and that's based on lidar and other methods, and a massive device support. So 5G has some attributes. One of the attributes is supporting number of devices, so UAV can help in that process. Ultra low latency, wherever you need a very quick application which requires a virtual network functionality and network slicing applications, you can use it with UAVs, and enhanced mobile broadband applications. Yeah, in fact, enemy can be killed by drones. That is a defense application. Usually, civilian research people will not have access to that research, but you can tie up with NDA non-disclosure with the DRDO and start working with them on some of those models. Okay, next please. Yeah, next slide please. Rapid prototyping. So we have additive manufacturing is 3D, intelligent manufacturing with UAV support in the shop floor. You are making some product, you want to monitor what's happening in the shop floor. UAV can be moving across the four corners of the room and capture all the things happening in the shop floor as per the norms. And if it is automation, any machine is not working properly, it can detect and report it. So that is a very value add of UAV for the five intelligent manufacturing. Okay, next slide please. Yeah, what about communications in terahertz frequency range? That is what will be called as a Li-Fi and a light fidelity. In fact, that is also 6G will take up those things. Automation is industry 5.0 or 4.0, and biggest advantage of that is bringing efficiencies, especially when people are let us say during COVID-19 we do not have manpower in a certain context. We can accomplish that remotely with UAV, where automation can be accomplished with that. Okay, okay. Next please. As asset management, RFID and remote ID. So basically, some assets can have an ID, and that ID can be tagged, and then you can actually manage the whole flow, and those IDs can be useful for your enterprise resource planning, and UAV can help in that asset management philosophy. RFID philosophy also can be attached to the UAVs. Remote ID also can be attached to the UAVs. Yeah. Next, please. So FDD, TDD, I mentioned if there is a single frequency for both the transmitter receiver to use, that is FDD. TDD, that is the TDD, and FDD is where you have one frequency for the transmitter, simultaneously another frequency for the receiver. In between, there is a frequency division duplex. And so we can have some kind of a push to talk over cellular, which can be manufactured. And UAV can be kind of a controller for all that in a event like a construction site or something. You can have a UAV hovering around to provide all the monitoring, and you can issue those devices to people, which can be like a makeshift cellular network is made, and UAV is controlling all that and shifting the location based on the requirements. Okay, next. Basically, what are the companies which are behind the making of these chipsets? As you could see in the ISRO's couple of slides, we have tech giants like Qualcomm, Broadcom, Analog Devices, Texas Instruments also making for the UAVs, the systems on chips. And based on that, the manufacturers which are already making telecommunication products, gears like Nokia, Ericsson, Samsung, even networking giants like Juniper, Cisco, they are involved in making some solutions using the UAVs for the 5G core and evolving 6G. So the communication providers thereafter will take these products and deploy it in their networks like RIL, AT&T, and Verizon Wireless. Yeah, please. So basically, the value that UAV brings to the table is the ability to move and in any direction, and also in the vertical direction in altitude, and internet and wireless on the move you will get, and unleash the aspirations of a nation of like 5 trillion economy in the short term, in the long term 15 trillion and beyond when you look at a decade and above. Okay, that is what is the role that of UAV will perform in the national aspirations. Okay, next slide, please. So basically, what are the aspects of 5G which are still relevant for the UAV? MIMO, massive MIMO, beam forming, ability to have multiple bands, multiple carriers. You can have some frequencies dedicated for the UAV customers and some dedicated for the ground-based mobile users. Like this, you can demarcate and manage the both the constituents in terms of their quality of service requirements of 5QUI. That is a core standard of 3GPP 23.20501. Yeah, next please. So basically 5G UAV, the advantages of depending on the new paradigms of openness and open connectivity foundation and software defined networks, virtual network functionality, network slicing, NFV network functionality, and MANO managed orchestration by HC. And these are all the attributes which make that viable, the UAV deployments a viable use case using 5G and going forward for 6G as well. Okay, next slide, please. So initially, how does that happen? So the telecom companies like Airtel, Reliance will soon will convert their network from 4G to 4.5G by bringing some efficiencies in their backhaul and front haul, and they will convert that into non-standalone, and finally they make it standalone on its own feet rather than partially 4G, partially 5G. And that requires a lot of improvements in the CPRI protocol, Common Public Radio Interface, which is the fiber optic between the electronics of the base station and the radio portion. There is a fiber connection, and also between the the core and the base station, there are a lot of fiber connections. That is called backhaul. Okay, next please. So the electromagnetic wave propagation characteristics also you should be good at when you are interested to work in the either wireless or UAV. Both are similar because UAV will talk to you through some transmission or reception, and they will be having a units like a dBm or a dB to measure the power levels. And you should know that 1 milliwatt is 0 dBm, 1 watt is 30 dBm, 1 microwatt is minus 30 dBm, and 3 dB means half power or double power, 10 dB is 10 times power, and like this you should know that. And power levels, values, measurements you should have. And also some things like a fading, 40 years of research that is done in the wireless right from first generation till date is still valid for the UAV industry because same rules exist, and fade margins to overcome that effects of mitigation to the nature of deterioration of signal strength due to propagation characteristics. Okay, next, please. So there's a lot of research. There's takeaways of collaborating UAV studies with 5G is a lot of things that you already mastered in the wireless. You can leverage to the UAV industry, and there's a lot of many multinationals have great drones, and China is one of the leaders in manufacturing them. A few policy frameworks are in shape to make the design considerations for Indian manufacturers. Navic is one of the great strengths of Indian manufacturers to insist that you don't import, but every drone that is to fly in India should be Navic compliant and not just as standby but as a mainstream. That would ensure the Indian manufacturers get their fair share in their industry. And people made flying machines like science fiction to look real. Yes, there are making some machines by connecting some compressed cylinders to their body and firing them. They are crossing the English channel, the in Lanyon to England in few minutes, and that they are doing it like a Superman flying. A person carrying this flying capable gadgets, they are able to navigate over the ocean in a few minutes. And there were questions in the beginning about air taxis. Uber air taxi is an example. There are some 10 different companies or 100 companies that hope to make, including Boeings and Airbus. They are interested in making these air taxis, and a lot of requirements of safety and protection, just like your car has got a, when a driver collides, there will be a safety air bag that gets released. Similarly, there will be requirement of safety in case a drone starts falling to the ground. How do you pick it up, or how do you make it less dangerous to the ground? All this we need to make all the necessary infrastructure, then only launch these services. So whatever you wish to do, you can do it. These are some of the things, like you open your mind, a lot of opportunities you will get with this technology. Okay. Next slide, please. Okay, I have a few additional slides. So yeah, let me just yeah, play that. Yeah, please play this one. Oh, this is played already. Yeah, we have seen this. Okay, we can move it quickly. It's a recap maybe. Yeah, 5G, the little bit kind of refresh. I mentioned 5G in my bullets, and this is a little graphical. So basically, we have broadband experience everywhere, anytime, smart vehicles that includes drones. So that's a vehicle which is connected, and there's a V2X, V2V. There's a 3GPP standard supporting the UAVs as a part of the wireless standards, and you can get a multimedia applications, and critical control of remote devices can be done with the help of 5G, which is also useful for robotic movement of the UAVs. And there is an interaction, human and IoT interactions are possible. Okay, next step, please. So we will wind up in 3-4 minutes. Yeah. So these are the three facets of 5G which is useful for the industry, including the UAVs of low latency, extreme high broadband of 10,000 times the whatever data rate you get currently. Whenever you do conference, sometimes we have device constraints, and 5G will mitigate those problems, and it will support 10-year battery life, and every 0.38 square mile you will get up to 1 million devices. That is the kind of a promise that this will give, and less number of packets being lost. One packet being lost in 1 million packets, that will be the quality that it will provide, and high reliability and low latency. Yeah, next slide, please. Almost I am done, and this is a award winning exercise done by the NASA people. They have achieved a award for collision avoidance using this inter USS communication, and using remote ID, vehicle to vehicle communications beyond visual line of control, using DSRC, which is also a protocol used in the autonomous cars. Between the lane change, they will be using DSRC, the short range communications, and all these are put together in their solution, detect and avoid, as we discussed. And this entire solution known as a the NASA government invention known as UTM award of 2020, June 2020. They got this award, one team that is working in NASA. Okay, you can see that utm.arc.nasa.com, and that is the source of this invention. Okay, the best practices to emulate. Okay, next slide, please. So basically, what is evolving with the 5G UAV is, we have one corner SDN, another is NFV and 5G, and at the bottom you have the layer of trust, which can be given from the blockchain to ensure security, so that there cannot be any drone with a bad intention flying around, and we can filter them out and take precautions against them. Okay, next. Geofencing can be done some areas where you don't want any drone to fly over those specific designated areas. Okay, next slide, please. NFV and SDN is clarified. I mean, a little bit of explanation is given here. We can move number of virtual network functionalities around this cloud of NFV, inside which there is a SDN controller. And so these are the three things which you need to master to build some applications on 5G with the use case of UAV or even beyond. So SDN is a flexible packet forwarding and steering of traffic in a physical or virtual environment. Another is NFV is a flexible placement of virtualized network functions across the network and cloud. Another is both are typically complementary tools for achieving the network programmability. So, the NFV is a functionality based, and other things are based on the physical environment based. Okay, next slide, please. So SDN and NFV do not depend on each other. They are mutually exclusive. They have virtual network functions inside NFV, and SDN has a open flow controllers, and we have got a demarcation between control plane and user plane. And there is connect between the NFV open flow controller plane software and the forwarding plane softwares, and together it's an ecosystem. Yeah, next, please. So basically SDN is one axis and NF is another axis. We can have this kind of forces acting together, flexibility in forwarding and processing. So NFV brings the processing and decoupling the functionality from the location, whereas the SDN brings the decoupling the control from forwarding, and together it's a good value proposition which can be leveraged for the UAVs also. Okay, next slide, please. Basically use cases for 5G drones. We have got news gathering applications for photography, videography, both civil and military, inspection of mining towers and factories, mapping of industrial applications, and also check water pilferage and leakage, agriculture, logistics, and in fact Geo is planning to use drones with facial recognition, and Samsung based drones are used to inspect antennas or base station from the ground. So Samsung networks equipment are used in Reliance even for 4G, and to send somebody to the top of a tower, it is difficult to do, especially in bad weather. You can now send a circuit pack required for the maintenance from a drone, and it will safely bring it to the place and go back, or it can also inspect them. What is the required changes that you need to do? Maybe electrically tilt the antenna, or maybe take care of some maintenance aspects. Those kind of things can be done through the drones. These are practical use cases of India for the drones from telecom infrastructure also. Okay, next please. So these are the some of the, this is the almost the last slide. So some quantitative results can be generalized about the practical results of drones and 5G. Connectivity is one of the 5G base station connectivity. In future it may be there, but right now 5G is not prevalent. So there are some handovers to 4G will happen. Even in future 5G base station may have to hand over to 4G. The drone has to have the capability to deal with that changes, and drones at a typical flight heights can have several hundreds of megabits per second over 5G. So basically most of the drones are restricted below 400 meters from safety point of view, because the pilots will do little bit of decision making until, depending on the weather reports etc., until 500 meters, and thereafter they will not be able to make any safe decisions thereafter. It has to be machine driven. So that is where the drones are asked to be below that height and not to interfere in the real aviation. 5G implementation used does not improve the user uplink throughput compared to 4G. This is one of the research done in the recent studies. So this needs to further investigation, especially as uplink is important for drones to send pictures and videos to the base station. So this is one AcSIR-CSIO org study report which we are presenting. This is almost the uh, so Tushar Mishra. Okay. Okay, this is the additional proposals. Proposed use of ping-based mechanisms, latency-based approach. Drone uses a 360-degree view of the 15 drones in real time. So we were able to keep 15 different drones and get one drone able to look at 15 other drones, and we were able to get the data in real time. And we were able to detect the near collision scenarios even using Bluetooth, and even aircrafts also use similar techniques. And handover between 4G 5G uplink speed is one area of research. using the peer-to-peer transmission for uploads, use of some list. Some you need to classify some drones as a bad or a good ones, and you can avoid them in the takeoff permission stage. Identification of rogue drones and auto calculate the drone health status based on the battery, payload, and temperature and age, so that you take scientific decisions to avoid any disaster. Okay, next. Yeah, you have some range restrictions of not near to the 5 miles or and
Yes, thank you, and it was really phenomenal. Yeah, so I think you have some network issue. Your voice is cracking. Yes.
yeah.
So most of the questions are already taken up from the chat box window. But still, I request participants if they have any other questions, so they can post it now, because we have received many questions and they were discussed during the session. If still anyone has any question, so you can post it here. So there's one from Deepak Kumar. Santosh sir, please could you mute yourself? Yeah. So we'll take the questions one by one. So Deepak is asked that what component is mainly from 5G to 6G communication? Sure, sir. Are you there? Can you listen? Hello. Yes, am I
Hello.
audible? Yes, Rishabh.
You are audible. Sir, are you there, sir?
Maybe sir will rejoin.
Sir, actually, we are not able to hear you.
So please try to turn off your video, save some bandwidth, and then turn on.
Sir,
Yes, sir. There. So in the meanwhile, the people who are asking for the feedback, I've shared the link. So you can fill the feedback form in the meanwhile. And people are asking for the PPT that we recorded the session. And the session will be uploaded on my YouTube channel. So you can get back to the people and clear doubts. So, Kishore sir, can you hear us? So please try to rejoin the meeting. So I would like people who are answering the question during the session. So thank you for sharing your knowledge. And this is the main motive of conducting these webinars, to network and to share knowledge. So I can see few people, like many of you are like sharing your knowledge by answering the questions in the chat box window. So thank you. Rishabh?
Wait for a second. I'm
Yeah, you
connecting.
can. So we'll take up these questions which were raised now as soon as I can. So in the meanwhile, if anyone want to like answer the questions from the audience and share your knowledge, so you are open. The session is open.
Okay, I think sir has joined again.
Okay, do you hear me?
Yes, sir. Now we can
Yes.
hear you.
Yeah, okay. In fact, um, I yesterday attended one NDTV discussion that's about education in India, and the
Okay.
journalist was asking the same question, which some of the attendees were talking about.
Yes,
Our
sir.
4G is not yet there. Why are we talking about 5G? So the NDTV's answer was, we need to have a solution. And so if we don't plan ahead, we will have still problems like what we are facing. So if 4G is not able to cope up with the network requirements, that is precisely the reason why we must invest on the 5G. That's a logical reason why we should upgrade our networks, so that we will cater to the bandwidth constraints that we may face today, because everyone is in networks.
Yes, sir. So, sir, we have a couple of questions in the chat box window. So, can you take up them quickly?
You can ask me, I will read out, I will give the answers to them.
Okay. So, the question, wait. Yes, sir. So, the first question is from Deepak. So, what component is an update to go from 5G to 6G? So, can you comment?
Okay, so basically any wireless, you will require a module that connects the command and control and user plane. So in the autopilot, you need to have a C2 link. C2 link currently can have frequencies like 433 megahertz, or frequencies like WLAN, and support for Bluetooth currently for smaller range. But for applications which require larger beyond visual line of control, you need to have the designated frequencies which your country allows. So in India, the regulatory's wireless planning cell, if they allow you the 4G frequencies, that module will sit right there in that autopilot. So it's not just the open source, the autopilot of Pixhawk or PX4. You need to have a dedicated autopilot with the command and control, with the communication capabilities of the wireless 4G and 5G, and going forward for the 6G. So the difference would be in terms of the transmitter and receiver and filters. For 6G would be using above terahertz range, like light frequencies, and that we are not yet there. It would be in 2025 onwards, 2030. So until then, 5G would be rolled out. Yes.
Yes, sir. Thank you so much. So next question is from Rajat. So he's asking, what effect would drones have on environment-friendly species like insect? On this?
Yeah, drones don't really harm them. Only thing is, we can use them for some applications where big fires, which are, Kandava Dahana, we say in Mahabharata or something. So, entire forest may be burnt if you don't take precautions in real time. So, drones can be helpful in those environments where big fire can be averted if by carefully monitoring it and then bringing in the required support to suppress or douse that fire. That is one example. Another thing can be any major catastrophe or an accident of on a road situation with kilometers of log of piling up of vehicles. All such things can be averted actually by giving traffic management correct feeds of speeding vehicles or erring vehicles by traffic monitoring purposes, or even the civilian surveillance can be done with the drone. So every product can harm nature. Any coal industry or any aviation industry with their for fossil fuels. So nature gets affected by industries. So drone in fact is much more cleaner in the sense it uses electrical power or even so much softer powers than the air traffic fuel of the flying aircrafts, which are one of the reasons for the global warming is air traffic fuel, which the drones are not using.
Okay, thank you so much, sir. So next question is from Indu. So ma'am is asking that what are the possible paths in which the drone move? Like move in straight, circular, or any other possibilities?
Yeah, it's a very good question. So it would work based on your flight planning. So it will take off and it has to go somewhere, do some task. It may go to one centralized place, get some instructions, thereafter go to a mission. And therefore, it all depends on your flight planning. And you need to do meticulous planning and approvals before that, such as NPNT and also the digital sky. I encourage you to go through Government of India, remotely piloted aviation systems, regulatory framework. They are all in the open space, and you can get in touch with us in BIS to get you more support on that.
Yes, sir. That's all from the chat box. If any of our participants
Okay,
want to
sir.
directly interact with sir,
Okay, so the birds. Mhm.
Yeah, it's a little bit off topic. Actually, since we were talking about facial recognition and image-based drones here, I would like to know, can you comment on the technology which can be used for the sound recognition-based drones or
Yeah, it's a good question, and that technology has not been developed because the drone itself generates quite a bit of sound, and so in fact, a drone intended to monitor some sounds. That's a research which we need to further look at possibilities of doing that. It's a good question. However, I do not see any of the industrially viable implementations of that.
I have read somewhere in the US Army there are sort of such drones which are having these capabilities.
That is true. In fact, as I mentioned to you, that defense has a lot of technologies. In India, also we have DRDO, and so defense technologies are not for the civil applications. So you will have a lot of implementations, and most of it will not be in the public domain. On you need to work through these different departments to.
Okay, sir. So kind of technology they are using to implement this idea in the defense?
Could you repeat the question?
Sir, any idea what kind of technology they are using in defense or some methods?
Technology used for
sound recognition.
Sound detected, basically acoustics. So basically you have frequencies from 20 hertz to 20,000 hertz is the audio spectrum, and the Nyquist criteria you need to go above that, like 40,000 hertz. So that is the scope of the activity that you should have. So you should have the very low frequency antennas, and they are very useful for some applications, especially for Navy support, and for maybe for between Air Force and Navy, or Army and Navy, this kind of applications. They are useful, but not for civilian application. You need to have specific antennas which are very long in their size, because low frequency means antenna size will be very big proportionately. Basically, velocity of light, when you look at the combination, you see if you want to put it on electromagnetic spectrum, very low frequency means your antenna size will be very big. So you need to have a strategy. How do you manage that large antenna size?
Thank you, sir.
Okay. Thank you, sir. So there are quick questions, sir. Two more questions have just popped in. One is from Vishnu. So he's asking that which type of batteries are used in drones?
Yeah, we can use lightweight materials made of carbon fiber, and research is going on with additive manufacturing. With even graphene is also a very good candidate, because it offers tremendous strength with very lightweight and giving you the structural integrity under stress. So graphene is one of the potential futuristic applications for the material use, but normally carbon fiber is used, and we can do 3D printing of them.
Okay, thank you so much, sir. So one last question is from Seema. So she's that possible to do inventory count, like reduce human efforts, ecosystem using drones?
Yes, yes. In fact, that is one of the use cases of serializing a product. After product is made, before you ship it, you can put some serialization using a QR code, and drone can use it to monitor that and then give you a kind of a auditing about, so that it helps you in better warehouse management and logistics supply chain of tier 1, tier 2, tier 3. That's a good question. So it is already being implemented.
So, sir, we have two more questions. Can we take them?
Yes,
Not,
yes.
yeah. Okay. So he tell me about flight drivers briefly, if you could
That's
comment.
right. So one example is PixHawk is from the PX4. If you go to internet, you will find the developer summit of the px4.io, 7 hours and 8 hours. During the early July, they have kept that continuous 7 hours and 8 hours of video recorded presentations by various developers, and where you will get to know about who is developing these flight controllers. Some of the companies like General Electric, Microsoft, they're also interested there. And so that's the best place to go is in YouTube. You have a px4.io recently concluded the developer summit, which was virtually conducted, and you get all the data about various companies which are making these flight controllers, and you get lots of data there.
Okay. So next question is from AJ. So he's asking that what are the in this
Opportunities in embedded
opportunities as embedded engineer in this field?
Yeah, because if you take up that blended learning program of IEEE, you will get to know about ARM Core Tech M series, and you'll know the programming. And even I know that Honeywell and Bosch, they employ people who are very good in embedded programming. And so if you know microcontrollers and 7851 like that, so definitely it is a very good upcoming field, and reliable, and it is useful even for your defense career aspirations.
So AJ, you can explore this field. Okay. So next question is from Kaushal. So asking that what is an autonomous car and when
In fact, already many trials happen, but not necessarily on our regular streets, but maybe they can do it in the Formula One race courses, etc. So autonomously flying cars and vehicles will be, in fact, if you look at our metro trains, they're all autonomously driven because there is no traffic for them. They are in one particular track. There won't be any train in front, and they can actually take a start and stop on their own. And but only in India we find that the metro trains are manned. But in Dubai, if you go Dubai Internet City and all, the metro trains, there is no driver inside. So autonomous vehicles are already deployed in Europe and USA. And in India, even people are talking about in Mumbai about Hyperloop and other projects. So we have to wait and see when that would happen.
Okay, so next question is from Vishwajit. So he's asking, sir, can we fly a drone by using Raspberry Pi?
That would be yes, but it would have a limited ground control station with your radio controls will be restricted in terms of their power and their range. So you will not be able to manage in a beyond visual line. So Government of India DGCA recently trained 34 different individuals from Zipline and Swiggy and Throttle Aerospace and even this Spice Jet. So they are all interested to get certified in future for their possibility of using them for supply chain or dropping packets like Amazon Prime Air. But you cannot do using Raspberry Pi beyond a certain visual line of control. But for academic proof of concept and prototyping, it may be useful. For what I suggest is, since you have nanotechnology capabilities in Chandigarh and also in Bangalore Center of Excellence for Nanotechnology. Just before starting the program, we were talking about it. That is the where you need to make a lift-off technology, lightweight, where I also worked for 1 year in Defense Labs, thin film hybrid microelectronics, two-dimensional electronics. That is the place to go for making a product which is very lightweight and have extremely complex circuitry in it, which will be lightweight on account of alumina substrate and plasma splattering and photolithography. So you do not use the traditional electronics because it will have weight on it. So you need to use this advanced nanotechnologies and micro electromechanical components there.
So last two questions. Okay. So one last question.
I think, okay.
Yeah. So it's asking which PLC controller family will be suitable for drones.
Yeah, in fact, you can use ARM core controllers, which we are already using it in Dona Aviation, but that is for small form factor of nano. But if you want to make a bigger realm, then you need to get in touch with Adanis and Abanis who are making small UAVs, and certainly they are not in the easily available realm. So we need to work through. So we have given some data, that is NVIDIA graphical controllers. That is also part of the story, which I have narrated already.
Okay, so that's all, sir. Thank you so much for a very informative and very insightful session. So before we end, I request everyone to turn on their camera. We can have a group picture with sir to make it more.
Thank you, sir. It was a great session, and I really loved hearing it.
Yeah,
Yes,
let me
sir.
have my camera on.
Yes, sir.
Apologies
My
for the
camera is
disconnection
switched on, blocked, I think. Can you enable my camera?
This is sir.
Do you see me in my
enable
camera?
your camera, sir.
And meanwhile,
Camera
participants can join.
on, sir.
Okay, no problem. You can edit it later. Yes.
Yes, sir. Yes, sir. I have your image. Yeah.
Thank you
What
so
else?
much. I appreciate
Sir, it's a
all the
pleasure to
questions.
have you. Yeah.
Yeah, thank you very much for all the questions, and your patient hearing, and I appreciate you having a lot of interest in this industry. I look forward to work with some of you because we ourselves are looking for talented people in this industry. Thank you.
So thank you all. Thank you, sir. Us, and the certificates will be mailed soon.
Thank you,
Please give
sir.
us some time as we are organizing webinars. We mail it like take time.
Okay, thank you very much. Bye-bye. Thank you very much. Thank you, Dr. Anupama Thakur, Rishabh, and the team. Yes.
Thank you, everyone.
Participants,
Take care. Stay
for us today. Thank you.
Bye.
Take
Seema
care.
Chaudhary. Okay, bye.
Yes. Yes. Thank you, Rish. Okay.